So students, we are going to discuss the center of mass of a continuous mass distribution. So students, we have seen that the discrete mass distribution, right, is if you want to find the center of mass, so that will be, let us say x COM is equal to summation mi xi divided by summation mi. So this formula can be used for discrete mass distribution. Now if you want to modify this formula for continuous mass distribution, then how can we do it? So I'll just give you an example for this. Suppose I want to find out the center of mass of a uniform rod. All right, uniform rod. So what is mi for it? Because mi is the ith mass. Let us say m1, m2, m3 and so on. So what is mi? So here I don't find any mi. So what I'll have to do, I'll have to take an element. So I'll have to take an element, and this mass of this element will be dm. So basically mi is dm. All right. What is xi? Xi is the position of mi. Xi is the position of mi. So here I'll have to locate that position of dm, right? And this is the position, this is the length dx. All right. And what is the summation? So the summation means you take the product of m1 x1, m2 x2, m3 x3, and you add it. So basically this summation is integration. All right. So I'll just remind you once again, this mi is the element, because there are many such elements, right? And xi is the position of that element. So let us say this is the origin. All right. So, and this summation is basically integration. So if I want to modify this formula for a continuous mass distribution, I'll have to replace the summation by an integration. I have to replace the summation by an integration. I have to replace this mi by dm and replace this xi by x. All right. And divided by, again, summation will be replaced by integration and mi by dm. So this is the formula which we are going to use for a continuous mass distribution. Similarly, if you want to find out y COM, this will become y dm by integration dm. Z COM can be found by using z dm by integration dm. Is it clear? Right? So this is how we can find the center of mass of a continuous mass distribution. So let us take an example here. So let us find the center of mass of a uniform rod. All right. So this is a rod. All right. So we are going to find the center of mass of this rod. So first of all, what we will do is we will take a particular element. We have taken this element. So this is at a distance x. We have taken this element. The length is dx. The rod given to us has a mass m and its length is L. All right. So we are told to find the center of mass of this rod. Now friends, this is length is x, this is dx, and this is m, this is L. All right. So first of all, the first step will be to find out this dm. So how do you find this dm? So we know that the mass per unit length, that is m by L, is given as dm by dl or dx. Okay. So using this concept, that is the linear mass density lambda, we can find the value of dm. All right. So lambda is linear mass density, that is how is the mass distributed. So in this case it's a uniform rod, so it's distributed as mass per unit length, that is m by L, or we can write dm by dx. So dm being an elementary mass and dx being the elementary length. So friends, from here we can get dm. So dm comes out to be mass per unit length into the mass of the required length, that is dx. So m by L into the required length, that is dx. So this is the dm. Now we have seen right now that how to find the center of mass. So xcom is going to become x dm by integration of dm. What is x? X is the position of the elementary mass. X is the position of the elementary mass, or we can say x is the center of mass of the elementary mass. X is the center of mass of the elementary mass. Alright, so x remains as it is because we cannot replace it by anything, and dm will be replaced by m by L dx divided by integration m by L dx. Alright, okay, so this m and L are constant, so we can take it outside, m and L, right? So this will become xcom is equal to, take m by L outside, so this is integration of x dx, and the limit of x is from x equal to 0 to x equal to L, so x equal to 0 to L, and divided by integration m and L. This m by L we can take it outside because it's a constant, and this remains as dx, so 0 to L. This m by L and m by L cancels out, my friends. So this becomes x raised to 1 dx. Its integration will be x raised to 1 plus 1 by 1 plus 1, that is x squared by 2, and this integration of dx will become x. The limit is 0 to L divided by integration, that is x from 0 to L. So on putting the limits, we'll get L squared by 2 divided by L. So L and L cancelled out, and hence we get the answer, that is L by 2. So center of mass of this rod is at its geometrical center, and which is at a distance of L by 2 from one of its end. So this is how we can find the center of mass of a uniformly distributed mass, or of a distributed mass. So this is the way. So we're going to use this formula, right, integration x dm by integration dm, to find the x coordinate, and similarly we can find out the y and z coordinates.